Discuss about two other methods that we can use to analyze circuits. So superposition and the source transformation method. Let's see how we can use it. I have mentioned superposition method is another method to analyze a circuit. The principle is for a circuit having multiple independent sources, we can consider the voltage across or the current through an element is equal to the algebraic sum of all the individual voltages or current due to each independent sources acting on acting one at a time. So dependent sources are never deactivated when applying superposition. So this means when we have many sources, current sources or voltage sources in a circuit, we can consider one source at a time and we can deactivate the other sources, and we can find out the current or the voltage just considering one source, and then we can add them to get the combined effect of all the voltage sources and the current sources. I will take an example and we'll do. So the steps here are: select one source and we turn off the other sources. When you turn off a current source, there is no current in that path. So current source, when you turn it off, that path will become open circuit. Okay, when I do a example, I will explain you more. When we turn off a voltage source, that path will become a short circuit. For example, if you have, let's say that you have a current source here and you have a voltage source and a resistor here. So you have something like this. So in this method, what we do is we consider one source at a time and we switch off the other sources. So for example, if I just want to consider the voltage source, I can switch off this one. When I switch off a current source, that path is open circuit. So that path is not existing. So that is open. Okay. Yes, we just ignore that current source and we only consider one source, which is the voltage source. And again, in the same time, so like after you finish with this one, you need to consider only the current source. In that case, you are keeping the current source, but you are turning off this voltage source. When you turn off a voltage source, that path will become short circuit. Okay, so let's take one example and we'll do it. Okay, so we are going to do this one. Here you have a voltage source and a current source. Okay, we consider one source at a time. So if I consider the current source, so they are asking us to find the V naught. V naught is the voltage across the 2 ohms. So we need to find the voltage across the 2 ohms when we have this circuit. So this circuit we have one voltage source and a current source. So if we are using the superposition method, what we do is we consider one source at a time. So let's do it. Consider the current voltage source only. So if I consider the voltage source only, I have to switch off the current source. All the other sources, I just consider one source at a time. So I'm considering the 20 volts and turning off the current source. So when the current source is turned off, what did we say? That will become an open circuit. So there is no path. No current means current is zero, means it's zero. It's open circuit. Now we can find out the voltage across this one only when we have 20 volts. How do we find the voltage? Can we find the current coming out from that? All the resistors are in series, isn't it? So when the resistors are in series, we can add them together so that the total resistance will be 10 ohms. Agree? So if the resistance is 10 ohms and the voltage is 20, what will be the current coming out from this one? What is the current? Voltage divided by resistance, and that will be 10 and that will be 2 amps, isn't it? So there is a 2 amp current going across all these resistors. Agree? So if they are asking us to find the voltage across the 2 ohms, so voltage is the current times the resistance. So resistance is 2, and what is the current going across the resistor? 2. So that 2 amps. So that will be 4 volts. So when you consider 20 volts only, and when we turn off all the other sources, the V naught 1, I just consider it as V naught 1, that is equals to 4 volts. Is that make sense? Any question? Are we good? Now we need to turn off the voltage source and we need to consider the current source only. So let's do that. So here we are going to turn off the voltage source. What will happen when we turn off the voltage source? That will be short circuited. So that should be like this, isn't it? Am I right? Now can we find out? So that's the current going to this node. This particular node is 8 amps. So 8 amps is splitting between two of these. So do you remember what is the current coming in to the right hand side? What is that current? Sorry, to the left hand side. What is that? How do we do that? Do you remember the current division rule? 8 times 8 is the total current times the opposite resistance. Do you remember? 5 divided by these two are in series. So that will be 5 plus 5. Do you remember this? You don't remember that? In the week 1? You were not in the class in the week 1. So that week it says, current division rule says if a current is coming to a node and if it is splitting between two resistors like this, R1 and R2. If you want to find the current going across the R1, I1 just if I take it as I1, I1 is equals to the total current times the opposite resistance R2 divided by R1 plus R2. That we call the current division rule. So we applied the same thing here. See, this is both together 5 ohms, isn't it? So the current is equally splitting. You even don't need the current division rule. See, 8 is coming and splitting between two similar like 5, 5. So it is equally dividing. So the current going across this side, left hand side is 4 amps. Agree? So if the current is 4 amps, what should be the voltage here? What should be the voltage here? V naught 2. Current times the resistance. So what is the current? What was the current on the left hand side? 4. So 4 times 2, which is 8. 8 volts. Am I right? So how do we know the direction of the positives and negatives? So positive side is this. Current should come to the positive side of a resistor. So that because V naught is positive, V naught 2 is positive and also V naught 1 is positive because it was going towards the positive side. Am I right? When the current is going to the positive side, the voltage is positive. I told you that. So what is the total combined effect of both of these will be V naught will be V naught 1 plus V naught 2. So what did we get for the V naught 1? Do you remember? 4 is, am I right? 4 amps when we consider just the voltage source, and this is 8. So 8 plus 4 is 12 volts. Are we good? I will give you one question for you to try and see whether you have understood. Okay, so this is what we got as the solution. Okay, I want you to try this one. You try. We need to find this I1, I2, I3. Okay, so we consider one at a time. So I first want you to draw the circuits. So can you draw the circuits? When just consider only 15 volts. Consider only 15 volts and turn off this one, and can you please draw the circuit? Then you can do it. I'll give you a few minutes. This is the circuit I got. Do you get the same? We turn off the voltage source, that will become a short circuit path. But you still have that 10 ohms. We need to find the I1, I2 and I3. You can use node, mesh, whatever the things that we have learned so far. You can simplify the circuit. It's up to you. So to remind you the things, okay? Because you have next week you have the test. So let's use node here. In the other ones we'll use mesh as well. So if I use node, do you remember what we have to do? Node. So do you get this circuit or not? When I turn off the 10 volts, did you get the same circuit or not? The same circuit, that's good. So node, what we need to do in the node? Yes, so how many nodes we have? We have one node here which we make it to 0 and another node here I just make it to maybe V1. Okay, then what we do, you assign currents. We assign the same currents, okay? I1 here, the I11, maybe I31 or an I21. Okay, so how do you do? The next step is what? You apply KCL to node 1. So when you apply KCL says whatever the current coming into the node is equal to the current going out. So what are the currents coming in? I11 is coming in. I21 and I31 is going out. Agree? Is that right? Any question up to here? Okay. Can you write, if you understood up to here, hi. Can you write these currents in terms of voltages? How do we write these currents in terms of voltages? Voltage, do you remember that last week? I1 you can write as starting from 0 minus 15 minus V1 divided by 5. Do you remember this? 15 minus V1 over 5 is I11. What is I21? Starting from V1 going to 0. What is the resistance along that path? 10. So that will be V1 over 10. How about I3? Starting from V1 going to 0 divided by 10. Am I right? So these are the three currents. Any question? Can you put the currents in that KCL equation, this one? And find me the V1, please. Yeah. It is 6 and 4. 2 is going across 6 and 4. So they are in series. So you can add them together. 6 plus 4 is 10. Isn't it? You can combine and make it to a single resistor, isn't it? Yes. I want you to find the V1. If you came late, if you have any question, you can ask. This week we are doing superposition and source transformation method. So we just started the superposition method. In that what we do is, when we have many sources in a circuit, we can consider one at a time. Okay, so here what we did was, this is our circuit. You can see the circuit. So we consider one at a time. So what we did was, we considered the 15 only. So do you see that? We considered only the 15 volts. When we consider only the 15 volts, that means this one, we have to turn off all the other sources. So what are the other sources we have here? We have another voltage source. So we are turning off all the sources, independent sources. So when we turn off a voltage source, that voltage will become 0. So voltage becomes 0 means that path is a short circuit path. So when you turn off it, this is a short circuit path. So we redraw the circuit only considering the 15 volts. Is it clear or not? Yes. So now you have just one source. So circuit is easy, simple. And we consider this, and we are finding the three currents, I1, I2, I3, only if we have 15 volts. So you can use any method that you have learned so far to find I1, I2, I3. But in this particular question, we are using a node voltage method, which we did last week. Remember that? Yes, so we did that. So what we do in the voltage method is, you first need to identify the voltage, the nodes. So in that we consider a node, consider nodes with 3 or more branches connected. So here we have 2 of them. Do you agree with me? So here you have 2 or more connected branches, and here as well. Then we assign a 0 voltage to one of the nodes, and then we assign V1 voltage to other node, and we apply KCL to that node. KCL says the sum of the currents coming into the node is equal to the sum of the currents going out. So the currents coming in is I11, going out is I21 and I31. Am I right? And then we write the currents in terms of voltages. So you already know I1 you can write it like this, I2 you can write it like this, and I3 you can write it like this. Then you substitute the values in this KCL equation, and you have only one unknown, which is V1. I told you guys to find the V1. All good? Yeah, so can you please find me the V1? What's that? 7.5. Who else got 7.5? 2 of you. Okay, so anyone else? So we can take it as the right answer, I hope. 7.5. So if V1 is 7.5, can't we find I11 currents? That's what we need to find, isn't it? The question they're asking us to find the currents. So can you please substitute the values and find me the currents I11, I21, I21, I31. So what do we get for I11? 15 minus 7.5 divided by 5 is what? 15 minus 7.5, that is 7.5. 7.5 divided by 5 will be 1 point something, am I right? 1.5 amps. I21 is 0.75 amps, am I right? I31 is 0.75 amps. So these are the currents along the 3 branches when we only consider the 15 volts. Are we good? Any question up to here? If you have done up to here till others will finish, you can consider just the 10 and ignore the 15. Okay, redraw the circuit only considering 10 volts. Okay, you have finished as well, right? So you can consider just the 10 and ignore the 15 and do the same thing. Can I move to the next part? Anyone need more time? No? Okay. Now we are going to turn off 15. Am I right? So when we turn off 15 and keep 10, you can redraw the circuit. So you have this this and you have 10 and 6 and 4. Am I right? Is this right? We'll do the node again, okay? So we have 10 ohms here, 10 volts, 5 ohms, 6 ohms and 4 ohms. So now only we are considering only the 10 volts and we switched off the 15. Now this will be our I12, this will be our I32 and this will be our I22. Okay. We are identifying nodes, so we have two nodes here. This one is our reference node, which is V is equals to 0, and this is V1. This is V1. Okay, V1. And what is the next step in the voltage method? We apply KCL. KCL to node 1 or whatever the number that you have given. So in that, what are the currents coming in? I12 is equals to I22 plus I32. Am I right? Now we need to write the currents in terms of voltages. So how can I write I11, I12 starting from 0 going to V1 divided by 5, and this will be negative V1 over 5. Are we good? Any question? How can I write I21 starting from V1 and going to 0, and the resistance, the combined resistance, series, 6 and 4 are in series, so divided by 10, and this will be V1 over 10. And what will be the I31 starting from V1 and going to minus plus 10, isn't it? Current is going into the positive side, so it is a plus 10 minus 0 divided by 10, and this will be V1 minus 10 over 10. Am I right? So these are the three currents, and you can now put the currents in the KCL equation and find the V1. Can you do that for me, please? So this will be I12 is negative V1 over 5 is equals to V1 over 10 plus V1 minus 10 over 10. So can you solve this and find me the V1, please? What's that? Yes, because these are the three currents we need to find, I1, I2 and I3. Those three currents are the currents when we have both 15 and 10 together. But we consider one at a time. So I just named in the previous one I1 1, I2 1, I3 1. But here just to make it different, I made it I1 2, I2 2, I3 2. So we have if you want to find I1, that will be I1 1 plus I1 2, isn't it? Because this is when you consider just the 15 and this is when you consider just the 10. So when you add both together, you will get this. The three currents only considering the 10. We switched off the 15. See, we switched it off. In the previous one, we switched off the 10 and we only considered the 15. So in the superposition method, we consider one source at a time and we switched off all the other independent sources. Other one we already found in the previous slide, didn't we? We found it, yes. So now we are finding the 10. When we combine both together, we get the combined currents. Yes.
How do you know that when we're going to use this type method?
You can use any method if in a question if they haven't asked you to use a specific method. But in your questions, as we want to test that you are okay with all the methods in the question we mentioned using the superposition method, find this. using the node analysis, find this. We ask you to use one of the methods. But in general, from first 5 weeks, you are learning different methods. So those different methods you can use as you want. But for your exam, we are asking you to use a specific method. So you need to know all the methods.
So up to now we have 6 minutes.
We have a basic concept in week 1. We have mesh, we have node, and here today we are learning 2 more methods. Superposition is this one which we are learning. We learned 5 methods at the end of today, and next week we are learning Thevenin and Norton, another 2 methods. So altogether 7 methods you learning. Okay.
And 7 methods.
No, in the test is next week, so only up to this week. Okay. Only up to this week, today's class. Basic concept, node, mesh, and superposition and source transformation. 5 methods. Are we good with this? What did we find for I1, I2, I11, I12, I22, I32? What did you get? What is V? 2.5. So V1 is 2.5. Do we all get 2.5 volts for V1? So what is I1? This one is what? I1, 2. This is negative 2.5 over 5. What is it? Negative 2.5 over 5 is negative 0.5 negative amps. Okay, so next one, I2 is what? 0.25, isn't it? And I32 is what? 0.75. Is that right? 0.75, isn't it? Did you get it or not? So did you get these 2, 3 or not? Which one is negative? Only one is negative, the first current. Okay, now to find, I told you, now you need to find the total effect. So in that case, what you need to do, you have to consider both the sources. So I1 is the current. When in the previous one, what did you get for I1? Do you remember that? 1.5 plus this. So what is the I1? Just 1 amp, isn't it? Is it clear or not? I1 is 1 amp. I2 is what? 0.75 plus 0.25, which is point. No. It's 1. And the next one is 0.75 plus 0.75. 1.5. I need to check this one. I think one is wrong here. Let me check. Did you the previous ones? I hope they are right. Can you check your answers here, please? Negative 2.5. 2.5 volts is right. Am I right? Is that right? Is 2.5 is right? 0.25. Yes, 1 is negative. Yes, you are right. So 2.5 minus 10 divided by 10 is, yes, you are right. This is negative. Yes, it's right. This is I32 is negative 0.75. That's right. So I3 will be 0, isn't it? 0.75 minus 0.75 is 0. So if you have done everything right, your I3 is 0, this is 1, and this is 1 amp. Did you get it or not? If you have any question, you can ask. You can try the next question.
But what we have to split one.
That's the method. That's the method. This method we call the superposition method. When we have many sources in a circuit, we consider one at a time.
For example, if we have three, we have to split.
3 times, yes. 3 times, yes. What was the question?
Is that I21 is the same as I22?
No. You remember? Go to the previous slide. I can't go back to the previous slide because I'm recording this one. It will spoil the recording. If you go to the previous one, you may have written it on your book. So I11 we got 1.5. I12 we got 0.75 and I13 we got 0.75. When you only consider 15, you got those 3 answers. Am I right? Yes, you consider one at a time and you switch off all the other ones. Yes, and you add all together. That's the method, okay? It depends on the circuit. Yeah, in this one you have to. Have we finished? Can I give you one question for you to try? Yes.
At the beginning, you wrote down like I12, I21, I31, right? At the beginning. And then you sub into I22, I32. Where is that?
Why? Because it's like this. When you only consider, you can put any names. I put like that. You need to, in the question, you need to find these 3. Am I right? I1, I2, I3. Isn't it? This is what we need to find. But these are the currents when you consider 15 and 10 both together. In the superposition method, we consider one source at a time. So in the previous slide, we only considered the 15 and we turned off the 10. Then you find the currents in this branch, and this branch. It's up to you. If you want to say ABC, you can put ABC. You don't have to put I1, I2, whatever it is. So this current is A, this is B, and this is C. It's up to you. These are just my symbols. They're just my symbols. You can have ABC, XYZ, whatever the things that you want to do. But the thing is, when you want to find I1, you need to consider A, and also you need to consider 2 currents. When you consider 15, what is the current? And when you consider 10, what is the current? You add those together and you will get I1. Make sense? You don't have to put any, these are just my symbols. I12 is in the second one. I22 is in the second one. I32 is in the second one. In the previous one, I used I11, 21, 31 because that was my first choice. This is my second one. Makes sense? Can you try this? You only need to find this I. Okay, simple I. What you need to do, you consider one source at a time. So let's consider just the 12 volts. Consider ring 12 volts only. So when you consider 12 volts only, you are turning off this. Am I right? So can you draw the circuit? What will happen to the current source when you turn it off? So no current means what? Open. So when you turn off the current source, your circuit will be this. Am I right? So you need to find the current here. So what you want to put? I like to put I1. Well, you can put A, B, C, whatever it is. So that my current, I'm considering it as I1. So you don't have to put I1. You can put whatever you want. You have to find the current across the 2 ohms, isn't it? Okay, so are you okay for drawing the circuit? When you turn off a current source, that path will become open and you get a circuit like this. Again, I told you, you can use any method. If you use basic concepts, I mean just simplifying resistance. 2 and 3 are parallel, so you can, am I right? So how do we combine 2 and 3? In the previous one, we used the node method. So if you consider this 2 times 3 divided by 5, isn't it? 2 plus 3. 2 times 3 divided by 2 plus 3. So the resistance will be 6 divided by 5, 1.2 ohms. And we have 6 ohms. If you do that, can't we find the total current coming out from this 12 volts? Can we find the total current? Yes, so total current will be voltage divided by the total resistance, 6 plus 1.2, 7.2. Do you agree with that? So what will be the current? Twelve divided by 7.5. 1.6 amps. Am I right? Do you get the same? So I get a current of 1.6 coming out from 12 volts. Do you get the same? So that current is coming out 1.6 amps. So it is going like this. When coming to this node, current division rule, can you find the I1? How this 1.6 is splitting between 2 and 3? Do you remember the current division rule from week 1? So what it says, total current, which is 1.6 times the opposite resistance, which is 3 divided by 3 plus 2. So that will give you the current across the 2 ohms. You can't forget this. So that will be 1.6 times 3 divided by 5, which is 0.96 ohms. Sorry, amps. So when you only consider 12 volts, the current across the 2 ohms will be equals to 0.96 amps. Do you agree with that? Did I do any mistakes? 2 times 3 divided by 5 is 1.2 plus 6 is 7.2. 12 divided by 7.2 is 12 divided by 7.2 is 1.67, and that times 3 divided by 5 is yes, this is 1. If we don't this is just 1, okay, because if we don't, this is 1.66, isn't it? 1.666, okay, or else we can say 1.67. So this will be 1 amp. If you round off, it will be 1 amp. Agree? Any question? Now if you have finished, I want you to do the other part. Consider the 4 amps only and find the current. Turn off the voltage source. I'll give you a few minutes if you have finished. Otherwise you can do and let me know whether I have done anything wrong. Okay, now when you consider the current source, what did we get? Current source only. So when you consider the current source only, you are turning off the voltage source. Am I right? So when you turn off the voltage source, what will happen to the that path will become So you are turning off this. So what will be your circuit now? This will be my circuit, agree? And we need to find this current. I'm just putting it as I2. It's up to you what you want to put. Did you get this circuit when you turn off the 12 volts? When you turn off a voltage source, that path will become short circuit. So how do we find this one? These all three resistors are in series or parallel or what? They all are in parallel. So you can add them, but I'm going to add only two. I just keep this one because this one we need to find the current across that. But I can add these two because they are parallel with each other. Am I right? All three are parallel, but we can just add two together. Agree or not? Yes. So when you add the 2 and 3, 6 and 3, that will be 6 times 3 divided by 6 plus 3, which is 6 times 3 divided by 9, 3, and this will be 2 ohms, isn't it? Is that right? So you can say, you can redraw the circuit like this. 2 ohms, 2 ohms. So this is my I2. Up to here, are we good? So 4 amps coming to that node is splitting between 2 and 2, equally splitting because both resistors are the same. So I2 is 1 amp again. Agree? Any question? No? Now how can we find the I? I is equals to I1 plus I2. Agree? Because I1 is the current when you only consider the current source. I2 is the current when you only consider the voltage source. When you add both together, which is 2 amps, when you add 1 and 1, that will become 2. And that will be the current when you have both sources together. This is hard. Why is that? Not because you haven't understood this. You have forgotten the things from week 1. So I have to refresh everything again. Then you feel like this is hard. I told you from the beginning, everything is connected. If you like miss week 1, week 2, it will be hard for you to understand the rest of the things. So you have to remember everything because they all are connected. Without that knowledge, we can't do anything. What's that?
2 or 4. Like you have I equal I1 plus I2 equals 1.
Yes.
I thought it should be 4.
The previous one with
I thought look at this.
You look at this and the 4 amps coming to here. Here, it's 2 amps. Sorry, 4 amps are splitting as 2 amps. Yes, I have done a wrong thing. So this will be 2 amps, am I right? Because 4 amps coming and splitting between these two, 2 equal. Is that what you are saying? Yes, so this is 2 and this will be 3 amps. In the previous one, we got 1 amp, isn't it? And now we got 2 amps, both together, that will be 3 amps. That's right. Yeah.
So like from now on, you combine the 6 and
3.
3, right?
Yes. You can combine all three, but no need, no point. All three are in parallel like this. It's like this. So 1 is 6, 1 is 2, and 1 is 3. So I'm keeping the 2. I keep the 2 and I adding 2 and 3, 6 and 3 together and make it to a single one. Single resistor because I want to find, I'm keeping this because I want to find the current across this one. If I combine it, I again have to split it. No point, no, so I'm keeping it. And I don't need the other two to be separate. So I'm adding those together. So I made it to a single resistor, and I left these two separately. So I can find the current across that 2, which is 4 splitting equally between 2 and 2, which is 2 amps. And in the previous one, we found this one as 1 amp, and this is 2 amps. So both together, that will be 3 amps.
So like if I combine 2 and 3, is that
you can combine 2 and 3, but the thing is, if you do that, you have to split it again, because you need to find the current across the 2 ohms, isn't it? You can combine these two, but no point. When you combine these two, you can find the current across both of these, but you don't want to find the current across both of these. You want to find the current across the 2. So I leave it separately. Otherwise, you have to again split it. You can find the total current going across both of these, and then you have to again split it between 2 and 3. Another additional step which you don't need to do that. Yeah, so you have additional steps, that's it. So it takes more time. Are we good with this? Any question? Can I move to the next one? Okay, I want you to try this one by yourself. Here we have 3 sources. You have to consider one at a time. It takes time, but I want you to try this because I want to see whether you have understood this. So consider one at a time. Okay, so you have to do three times, and you need to find the V note. I'll give you time for you to try. Okay, so it's like this. You consider one at a time, so you need to do 3 times. So you consider 12 only. When you consider 12 only, your circuit will look like this. This will be your circuit when you only consider the 12. So you have 12 volts, and you have 6 ohms, you have 3 ohms, you have 5 ohms, and you have 12 ohms, and you have 4 ohms. You need to find the voltage here from here to here, V naught 1. Okay, and then that is only when you consider the 12. So that is your one circuit. You need to do this and solve this and find the V naught 1 from here. Okay, you can use any method. You can use mesh, node, anything, and you need to find the V naught 1. And if you consider 19 only, what will be the circuit? So you have 6, and you have 5, you have 3, 4, and we have the 19. So your circuit will be like this. So you have 19 volts, and you have turned off all the other ones. And you have to find again the V naught 2 here. So find the V naught 2 when only considering the 19 volts. Again, you need to turn off all these two, and you have to consider only the current source. You have 2 amps. Is it clear now? And you need to consider the voltage from here to here, maybe V naught 3. So V naught 3, just find it, and your V naught will be V naught 1 plus V naught 2 plus V naught 3. Okay, some can be negative, so you have to let's see, try. So you can use any method that you have done so far and find this voltage across the 5 ohms. You can combine 12 and 4, that's right. But how can you combine 6 and 3? Are they in parallel or series or what? 3 and 12. No. If you say these two are parallel, then there is something in between them. If some two are parallel means they should start and end with the same node. But here you have 5 in between them, isn't it? So 12 and 3 are not parallel, but 12 and 4 are in parallel. Sorry, is it 12? 12 and 4 are in parallel. That's right. So you can combine it. So if you combine this, it is 3 ohms, isn't it? Now 3 and 5 are in what? And you don't do that because, like, you need to find the voltage across the 5. Just leave it. It's easy to keep this one. V01. You can use node now. Can we use node? You can use mesh, whatever you want. What do you want to do? Let's do mesh to refresh your memory on mesh. Okay, if you have started something, that's fine. So I'm going to use the mesh to refresh your memory on mesh. So here we have two meshes. I'm assigning a mesh current I1 and this is my I2. So I'm going to apply the KVL around the meshes. So if I apply the KVL around mesh 1, KVL to mesh 1, I start at a point and going around here. So negative 12 because I'm coming into the negative side plus 6 times I1, or else I can say 9 times I1 minus 3 times I2 is equals to 0. So I can write I1. I can divide everything by 3. So I can say negative 4 plus 3I1 minus I2 is equals to 0. I can say I1 is equals to 4 plus I2 over 3. I'm using mesh to revise your, yes. Yes. So for node KCL, for mesh KVL. And I'm applying KVL to mesh 2. So I'm going around the mesh and I can say 3, 6, 7, 8, 9, 10, 11. 6 and 5, 11. So 11 I2 minus 3 I1 is equals to 0. So I can say I1 is equals to 11 I2 divided by 3. So these two are equal. So I can find I2. So I can find I2, which is equals to 11 I2 over 3 is equals to 4 plus I2. So I can over 3. So I2 is equals to 10. 4 divided by 10, which is 0.4 amps. Isn't it? We need to find the I2 is the current going here. This is the I2. So the voltage V01 is equals to current times the resistance 0.4 times 5, which is 2 volts. Agree with me? Any question? Did you get the 2 volts when you only consider 12 ohms? Sorry, 12 volts. You can use any method, but we still should get the same answer even though the method is different. Are we good? Can I move to the next one where we are considering only another source? If you need time, we can wait. You need time? Yeah, you take your time. When you consider the 19, you can do in the same way. So we can add this 6 and 3 together. In this one they are parallel, isn't it? 6 and 3, are they parallel? I'm again going to use the mesh, because just to, so 6 times 3 divided by 9, which is equals to 2 ohms, isn't it? And this will be 5 ohms, 4 ohms, 12 ohms. Then we need to find this voltage we know 2. I'm going to use the mesh again to remind you the mesh method. So I'm assigning two currents, I1 and I2. There are no super meshes here. So I apply KVL to mesh 1. I start at a point and go around this. So I have just 5 plus 14, 19 I1 minus 12 I2 is equals to 0. So I can find I2 is equals to 19 I1 divided by 12. And then I can apply KVL to mesh 2. So we have start at a point and going around. So 12 plus 4 is 16 I2 minus 12 I1 plus 19 is equals to 0. So we can say I2 is equals to 12 I1 minus 19 over 16. So I got two values for I2. Am I right? Is that right up to here? Do you remember the mesh? Is this right? Did you get the same? Did you use the mesh, or you can use any method? That's fine. But I will do this one with mesh. Now I'm equaling these two. So 19 I1 over 12 is equals to 12 I1 minus 19 over 16. 4 times 3, 4 times 4. So we can then cross multiply. So I have 4 times 19 I1 is equals to 3 times 12 I1 minus 19 times 3. So 19 times 4 is 76 I1 minus, so 12 times 3 is 36. 36 I1 is equals to negative 19 times 3. So 76. So I1 is a negative value. I1 is negative 40 over 19 times 3, which is 0.7 negative. I1 is 0.7 amps negative. Is that what you get? I1 or I2? Which one is that? Let me check. Let me check whether I have done anything wrong. I still get this. Yeah, I still get this. Is that wrong? What's that?
I think it's 1.4. I1 is 1.4.
Did anyone else got that? Anyone else got it? I did twice and I still get the points. Negative 0.7. Let's wait for one more. Yes, so my bad. So it is not 40 divided by this. It should be other way around, sorry. So that will be 19 times 3. 19 times 3 is 57. So negative 57 divided by 40. Is that right now? So divided by 40, which is equals to negative 1.425 amps. Is that right? Now you can see here. Voltage is, current is a negative value. So our voltage should also be a negative value. Do you agree with that? Because current is not going to the positive side, it's opposite direction. So your voltage, we know 2 is I1 times 5, but your I1 is a negative value, which makes your voltage also a negative value. Makes sense? So when you are substituting I1, you have to substitute as a negative value. So this will be 7.125 negative. Does that make sense? V2, we know 2 is a negative 7.125 because your current is not going to the positive side, it's going to the negative side. It's going other way around. Negative current means it's going other way around. Agree with that? Negative 7.125, yes. Yes. Which two are parallel? For to become parallel, they should start and end at the same node. Okay. So fine. These two are, yes, starting from same node, and this one is node is where you have connection. So you have this one is finishing here, this one is finishing here. In between these two, you have something, isn't it? So when you have something in between two dots, it's not. So but here, see this 3 and 6 starting here and ending here. So see, there is nothing in between. They are starting and ending at the same points. Any other questions? So we have one more, okay? So we'll move to the other one. Now we are considering only the current source. I want you to do this. Let me check the time. Okay, so we will finish with the superposition method today. And we have done a lot of questions. So Thursday morning you have practicals. And then I'm going to do the source transformation. It's easy. And we'll do other questions in the tutorial as well. Okay. So I think with these questions you are good with superposition. Am I right? Are you guys okay with superposition? I think we have to finish. It's 10 minutes. How can we? I will quickly do this, okay? Otherwise, so these two are in parallel and these two are in parallel as well. Agree? Am I right? Both are in parallel, so you can convert it to a single resistor. So with this one, that will be 12 plus 4, 12 times 4 divided by 16, and this will be, we already did this, 6 times 3 divided by 9. This we got 3, and here you got 2. Am I right? Any question? And we have this current source, 2 amps. Am I right? And these two are now in what? These 2 and 3 are in what? In series. See, they are in the same path. Aren't they? They are in series. So you can add them and you can say that is 5 ohms and you have 5 ohms and you have a current source of 2 amps. Is that right? So this current 2 amps coming to this node and splitting between 5 and 5 equally. So this will be 1 amp each. Agree? So the voltage across this one V node 3 is equals to current times the resistance, which is 5 volts positive. Am I right? So we have all three voltages. So you can find the V node, which is V node 1 plus V node 2 plus V node 3. Do you agree with that? Any question? Are we good? Are we good? So we'll wind. Yeah, what's that? Which part? So you.
When we combine that together, we have 5.
Yes. So 5. So 2 amps coming here. 2 amps coming to this node, and it is splitting between 5 equally. Both are equal resistance. So splitting between these two, 1 amp each. So current going across the 5 here is 1 amp. So current times the resistance will give you the voltage, which is 5 volts. And then you have to consider all three that we have found so far, these three. You remember the previous steps? V naught 1 plus V naught 2 plus V naught 3. We are adding all together, then we get the V naught. Are we good? We have to wind up the class because I think other teacher is waiting. So we are going to do the, we have a little bit time. However, if you need a little bit more time, you can write this down and I will do the source transformation on next class, okay? Any question?